My name is Tom Gibbings. I'm the Market Development Manager for the Helix Cloud Business Unit. I'm part of the Wind River organization, which is a subsidiary of Intel. We were purchased in 2009, and yeah, we're part of the Intel family. I'm based in San Diego and spend a lot of time on the road flying to various places. So the title of the talk today is Using Device Lifecycle Management to Future-Proof Your IoT Deployment. I'm going to keep it fairly short today with the content so I can leave a good amount of time to have Q&A, and hopefully you all agree that I'll get to the point rather quickly. I attend a lot of these web sessions and there's always great titles, and then I'm wondering, like, when are they going to actually get to the point of the entire talk? And so, since that's a pet peeve of mine, I'm going to go ahead and get to the point rather quickly. All right, so we all know the story. The Internet of Things is exploding, connecting things that were never connected and changing the way we live and work. From shoes and home appliances to cars, water pipes, and smart devices of all kinds, they're now connecting and sharing data. IoT enables people, businesses, communities, and countries to turn that valuable information into actionable insight. So just a little bit more level setting here. I know you're probably all familiar with the huge numbers associated with IoT, but I'll put a new twist to it in the next several slides. So those big numbers are, there's going to be over 200 billion IoT sensors connected to over 25 billion devices, producing over 40 zettabytes of IoT data. And so this is supposed to happen by 2020, so we have about 2 years to do it. Many of the businesses today are taking advantage of IoT solutions, so let's look at a couple of these examples. And these are fairly well known, so they might be familiar to you. This GE is using IoT sensors to remotely monitor their turbines, and it's helping them to do predictive maintenance to avoid expensive customer downtime. Tyco, they're connecting their safety panels, enabling automated reporting and significantly reducing their maintenance costs. So just as an aside note here, reducing the maintenance cost is one of the best used examples of how you justify investment in IoT. There's soft costs and hard costs in IoT when you look at a project's ROI, and service costs are one of the hard costs that help you justify it. So for all of you out there that are trying to justify your IoT project with your executives, focus on those hard costs. The soft costs those are an added bonus. All right, moving on to Tesla. They were able to remotely fix 30,000 cars and creating a hassle-free customer experience at the same time as reducing those service costs. And so in this example, the hard cost would be reducing service costs, and the soft cost, or the soft benefit, would be the hassle-free customer experience. Okay, and Diebold, they were able to dramatically cut ATM service costs by using IoT to monitor devices and enable remote service. The long-term success of your IoT deployment will depend on your ability to address several technical and business challenges. Most people, they start off by focusing on the data. They think to themselves, what kind of data do I need to collect? How often do I need to collect it? And everyone just dives right in. What is the data story? But there are several technical and business challenges that you have to also address. Otherwise, you will put in jeopardy your entire project. So you can see this list of concerns here. Security is a big one, and we're going to talk about that in a minute. In addition, you'll see other technical topics such as remote service and software updates, which are critical to keeping your IoT deployment fully operational. See, it's not enough to rely on tools like SSH or Yum or apt-get or whatever tool that you use to update one computer. You need to have that functionality at hyperscale. It has to be on budget, which means cheap. It has to be secure, and you need it now. So speaking of security, let's just address that head on for a second. So we've all heard the stories. We've heard the Stuxnet one. That's a real popular one. The Target HVAC attack, and the most famous IoT hack to date, which is Mirai. We most recently saw the crack compromise, which essentially obliterated WPA2. And well, where am I going with all this? IoT is much more than just data and analytics. Yes, analytics is an important part of delivering the value proposition of IoT, But in order to realize the true value, you have to address these other technical and business challenges at the same time, or you're going to find yourself in a lot of trouble further down the road, right? And so that's the point here. A down device is not sending you the data that you wanted. And that is where secure device lifecycle management with Wind River Helix Device Cloud comes into play. I have this is the obligatory plug here. So it's with device lifecycle management capabilities, this is how you future-proof your IoT deployment. The data collection is the easy part. We can do that, many other people can do that. And what makes us different and device management lifecycle platforms different in the general sense is that we are focused on the really hard stuff, that hard stuff related to device management. And it's also the reason why Wind River is making an aggressive move into the IoT platform space. So if you don't know about Wind River, we have been solving the tough problems in embedded for over 35 years. Our flagship product is called VxWorks. It is a real-time operating system for embedded devices. So we've been in this space as long as it's been around. So let me walk you through device lifecycle management. So it's not exclusive to Wind River. We are in an ecosystem. There's several players out there. But this is our view on device lifecycle management and what it means to us. So you see the 6 boxes. These are the 6 phases of the device lifecycle as we've defined it. It starts off with deployment, right? You got to get your device in action. And this first problem, it's related to the value and supply chain. And this is a real tough one. To keep costs low, a manufacturer needs to make millions of devices with the standard Linux image. However, the end user needs devices that can be deployed for a variety of use cases without having to configure each device. So think about this for a minute. How are you supposed to deploy 100,000 devices if you have to implement a heavyweight staging process that involves a technician unboxing a device, turning it on, configuring it, turning it off, reboxing it, and labeling it, and doing whatever else? So the problem is that you don't. If you have a large deployment, you just can't have that kind of process. It has to be automatic. And this is a huge problem, not just for a few customers, but it's a big problem in IoT right now. It's just not talked about that much. So Device Cloud is integrated with Intel Secure Device Onboard technology to solve this problem. It's fairly complicated, and since this is a developer crowd, I'll do my best to do a short summary of it. So there can be an hour presentation on this alone, and there might be. But the short version is that when a device powers on for the first time, it reaches out to an Intel rendezvous server, which gives the device its onboarding package that contains software to install. So in this case, it would be the Device Cloud connectivity agent and configuration files so that a device can connect to Device Cloud and be managed remotely. So then Device Cloud takes over from there and completes the onboarding process through additional packages and everything else. And so there's a big part that I skipped in this, and that is the concept of an ownership proxy. And that matches the device to the owner so you can get the right onboarding package for that device. So you can learn more about this with the Intel Secure Device Onboard lecture. So they're having one today, or at their website, and Google, of course, knows all about Secure Device Onboard. But bottom line is that if you're familiar with hardware root of trust, we have a hardware root of trust, and that is what protects the device. And you have something called an ownership proxy that follows the value chain. And when those two things are matched up, it produces a package that's installed on the device. It's installed, and then off you go. You avoided your heavyweight onboarding process. Okay, so now back to device management. We have 5 more phases of your life cycle. Once your device is on board, then you can start monitoring. And this is what most people are familiar with when they think of IoT. So the device is onboarded and properly configured, and it starts to send data to the platform. This includes both sensor data and device health metadata. And this ties back to our theme that, yes, the sensor data is extremely important. It's the reason that it's pushing your IoT project. But it's also critical to send the data associated with device operations. Because if that device goes down, your data feed is dead. Your data feed goes down with it. And when you have to send a technician out to physically interact with that device, then you are compromising the IoT premise, because sending people out to do a sneaker net operation, that's totally 80s by now, right? Okay, so that brings us to service. So in order to prevent this truck roll, you have to be able to service it remotely. And that means that we have tools like SSH, file send receive, log management, etc. And what's really important about these features is that you need to be able to have a single click launch of the features so that you don't have to bring up new tools. Here's an example. If you wanted to SSH into your device, one way to do it is you could set up a tunneling technology so you have port forwarding between your computer and then the device, and then you fire up your PuTTY tool, you type in the IP address of your device into PuTTY, you hit connect, and then you have your command prompt. That takes like 45 seconds to do. A product like Helix Device Cloud, you locate your device on the list, you hit the SSH button, a window pops up, there's your login prompt, and you're done. And so when you start adding up these tasks and you start shaving 30, 45 seconds off here, there, everywhere, all of a sudden you're able to be a lot more effective with managing large deployments. Next is management. Okay, so when you have a large fleet of deployed devices, you're going to have to track various properties that describe the device. You're going to have to know what software is installed where and what device has what hardware. After you have had several phases of deployment, you'll start to have things go out of sync. You're working with an ODM, and they give you Rev 1 of the hardware, and you made a tweak to it, and then they give you Rev 2, and then all of a sudden your deployment has several revisions of the hardware, and you need to know what is where. And so that's where management comes in. You have to track all that information. Okay, update. So remote updates is probably one of the most important features that Device Cloud has to offer, and it's one of the most important features in your device lifecycle management strategy. So going back to our security story that we discussed earlier, like Mirai and WPA, those are solved with a remote software update. You're always going to have something that's found, like, for example, the Heartbleed bug. Everyone remembers Heartbleed, right? That's solved with a remote software update. But not only is it critical to deploy the updates at scale, but you have to be able to configure the policy associated with each update. And so I was referring to some of the common tools. If we have some Linux gurus in the audience, I'm sure we do. And you have Yum, apt-get, and those sorts of tools that are out there. But if you have a million devices, you're not trying to SSH in all one of them individually and run your command. You need to do that at scale. And so that's where a device lifecycle management tool is really handy, is because you have stuff to do that, and that's where our update story comes in. We call these mass updates, we call these campaigns. And a campaign is essentially a policy associated with each of these updates. It is how you control which set of devices receive the updates, when that update occurs, and what dependencies you have with that update package. And in Device Cloud, the concept of campaigns, it's not exclusive to software updates, but extends to device actions, which means that you can define an action for a device and deploy it at scale. Suppose you need 10,000 of your devices to reboot, no problem. That's a really simple campaign. You need to execute a script on all devices with software version 1.2 installed. We got you. It's super simple. All right, now that we've covered update, let's move to decommission. Decommissioning is all about when your device has served its useful purpose, you want to dispose or repurpose it. One of my favorite examples is when the cable guy comes to replace your set-top box on your TV. They're going to take that, refurbish it, and redeploy it. And so they're going to want to delete some of the data, like your customer data, but they're not going to want to completely brick that device, right? But then there's other times where you want to completely brick the device. And for those not familiar with that term, bricking device means you do something to it that makes it completely worthless and breaking it. And an example would be, suppose you have a geofence on your device, and you're going to assume that the device is stolen if it travels outside of that geofence, and so you want to send a poison pill. And so you could have a rule that triggers that when it's outside your geofence, send the poison pill, and it deletes all your certificates and deletes everything that's useful data for any sort of attacker, right? And so once your certificates are gone, then you can no longer connect back to the platform. And so that's what we would call breaking a device, is by deleting all the certificates. You can't get back into it. All right, so bottom line is that you want to delete data, perhaps the certificates, and otherwise influence how the device connects. You need to have a set of tools to implement that behavior, which is where decommissioning as a topic comes in. So that is device lifecycle management. And now let's move on to the next phase of our story on why device lifecycle management is so important. So we go back to our Gartner forecast, which I mentioned a few minutes ago. So I was saying that there's 25 billion devices anticipated to be deployed by 2020. The forecasts are all over the map. Some people say 50 billion. I think Cisco is saying 75 billion. The point here is lots of billions of devices. And the point I make, it will translate to either of those forecasts, so I'm just choosing one. I like this one because they gave year-by-year granular data in their data set. So if you take a look at this data set, in 2017, they say that we have deployed 8.4 billion devices by this year. When we looked at this number, we wanted to know, of these 8 billion plus devices in 2017, how many of those devices are being managed today? How many of those units are future-proof with remote service and update capabilities? And how many are at risk? So we did a survey, and we were able to access 100 different managers at various companies that are either deploying IoT devices or getting ready to deploy these IoT devices. And we asked them about their device management strategy. Now, a major assumption here is that this subset of 100 represents the entire market, and that's debatable, but you know, we can adjust these percentages up and down. The findings that we have remain the same. So this is one of our 20 questions, and it was, how long will your current solution address your device lifecycle management needs? And the answers that we got were a little surprising. 26% said they didn't have a solution in place, nothing. 40% said they have something in place now, but it'll only get them through the next couple. And then 16% said that they would be good for 2 to 4 years, and that next gives us the long-term people, so 4+ years. So those that have long-term solution is 18% of respondents. So let's do a little bit more digging in this statistic. We focus in the industrial market, and in the industrial market, we can assume a 5 to 10 year lifespan for each of the devices, and in some industries like oil and gas, it can be up to 20 years and even longer. All right, so we know that our typical IoT device will be out there for more than 5 years. So if we say that 5 years of our threshold, then we can reconfigure these numbers to be binary, right? You can either say you either have a long-term solution or you don't. And when you look at it through this lens, that means 82% of the respondents of our survey do not have a long-term device management strategy in place today. And this is really scary because for large IoT deployments, let's say you have a large IoT deployment that connects via Wi-Fi, and you can't push a remote update to respond to the crack attack on WPA. Now you're looking at a really expensive sneakernet project. You're going to have to get a subscription to Nike or something because you're going to be out there for a long time, right? And the point here is that you have to have a strategy in place for when this kind of stuff occurs, or else your whole deployment is toast. So we've known from talking to people that device lifecycle management was often overlooked, but we didn't really know how often it was overlooked. And so we're getting to the punchline here. If you want to future-proof your IoT deployment, you have to be in this yes category. If it's not with Wind River Helix Device Cloud, then you need to do it with something else. All right, let's explore this a little bit more. I've already made my point, but it's helpful to me to translate those percentages into hard numbers so that you can know how many devices we're talking about here. In the green, this represents those devices that have an associated device management solution for the lifespan of the device. And yellow means they have short-term solution in place, but not long-term. Many of you might be asking, well, what does that mean? How can you have kind of a solution? Well, there's several scenarios. The two most common are, number one, you have a homegrown solution that doesn't scale and you need to scale. So it kind of works now, but it won't long term. That's probably the most common, is that people most often, they don't want to go buy a platform. They want to use Microsoft Azure and AWS tools and not a purpose-built platform. So they cobble together their device lifecycle management strategy with those tools, which is essentially homegrown. That's not a long-term solution, right? And so you have to have a purpose-built platform for device lifecycle management, or else you're in this yellow category. It could work kind of for a POC project. Anyways, another common one is end of life. So we have customers that have products that are end of life, and they're going to be no longer supported in the next year or so, so they're looking to migrate. So yes, IoT has been along long enough that people are migrating from one solution to the other. Lastly, those in the red, those are the subset of devices that do not have an associated device lifecycle management in place, and these are the ones that are a security risk for their customers and the entire industry. So frankly, whenever we see stuff like the Mirai attack, that's egg on the face of the company who made those devices and the vendors involved in the bill of materials for that device and the entire industry. So we don't want to see any more of that stuff out there. All right, so the hard numbers are, today, at risk, 6.9 billion devices, and the ones that are clearly unmanaged, 2.2 billion. So you can assume that there's going to be a ton of devices out there that can't push a fix for WPA, right? In 2020, if things go as they are, then we're going to see 16.5 in the at-risk category and 5 billion that are unmanaged. And so I know that many of you in the audience today, you will be deploying IoT devices in the field by 2020. Please make sure you're in the green. All right, so back to Wind River Helix Device Cloud. Device Cloud makes it easier at every stage of the device lifecycle, starting with flexible deployment options, which means that you can have public cloud that's multi-tenant or on-premises that is a single tenant. Customers can monitor, service, and manage devices remotely from one single platform or single pane of glass, which means single user interface, and execute your updates quickly and easily and cleanly decommission your devices. So let's get into the weeds now. All right, what is device management when you get into the weeds? Of course, our context will be the Wind River Helix Device Cloud. It all starts with the software agent that's installed on the embedded OS. You can see this on this diagram with little gears that are on your little IoT devices. You have the robot arm, your gateway icon, et cetera, et cetera. So you have an agent. That agent interacts with device sensors and collects the data through applications built by solution providers. These applications are built using Device Cloud APIs. So the key takeaway here is that you have an agent that has APIs that you can build on top of, and it makes it really easy to send your data up. The data is then sent over an internet backhaul, so pick your protocol, Wi-Fi, cellular, Sigfox, whatever. Then the Device Cloud includes a management user interface that acts as the console for interacting with the devices. And a large part of our extensibility story is with RESTful APIs. Our philosophy is that any capability that is available through the management console, it needs to be exposed via REST so that customers can integrate those capabilities in their vertical specific application. So one of our customer favorites is the custom actions capability, where a device callback function on the device is registered with the platform and exposed via REST. So what this means is that if you want to create a button on a website or any custom application that turns an actuator on and off on your device, you can implement this functionality using Device Cloud Custom Actions. And this capability is a generic framework, meaning you can create any user-defined custom action on your device, and it will automatically be created or available via REST. And so the point here is that we take care of all the plumbing between the device and the cloud, and you can use standards of APIs on the device and REST APIs on the cloud, and we take care of all the hard stuff in between. All right, so while device cloud can and it should be used as the data egress, long-term data storage is outside the scope of the intent of the platform. And the Amazons and the Microsofts of the world, they do this very, very well. So we focus on getting the data off the edge and forwarding it to the long-term storage vendor of your choice. This is done with a combination of a rules engine and enterprise service bus and MQTT streams. We have a OS that's on top of everything, so you just go and configure it, and we take care of everything behind the scenes. But just to give you a little insight on how that all works, AWS and Azure, they are great for long-term data storage, anything related to analytics, right? Big data analytics, they do that stuff great, and we are all about getting them the data as fast as we can. Last thing is our mention of security again. Since Wind River is a subsidiary of Intel, we have been able to collaborate with them on providing a solution stack containing a chain of trust that starts with a hardware root of trust in the silicon and extends into the cloud. And so we're big believers of hardware root of trust. Intel has taken its lumps over the years and forced us to understand why that's so important. And so we are embracing that wholeheartedly. Oh, there's still more buttons there. Look at that. Okay. Let's do a little bit of a deeper dive into the agent and agent technology in general. So this is probably some of the most technical content I have for you today. So IoT platform providers, they typically have to provide two types of agents. One agent for gateway class devices that contain one of a variety of operating systems. Unfortunately for us on the vendor side, the scope is quite broad and includes everything from traditional desktops and even server class machines to more constrained devices that run operating systems like Android or Yocto. The other part of the agent strategy includes resource-constrained devices like microcontrollers and bare metal installations. This makes it tough for platform providers who write the gateway agents code to assume things like an operating system and a file system, right? So in our gateway agent, we have file send receive, and then when we take that down to microcontrollers, oh wait, our file system's gone. What do we do next? And so this just creates additional burden for the platform vendors to provide the C++ code, so you can compile it into your device image and get it going from there. And so since we have a long history in embedded, we're able to do that fairly easily, but a lot of other vendors may have some challenges doing that. But what I want to focus on is the gateway agent and the gateway agent approach. So IoT is, even though it's in its infancy, it's been around for a while, and there are a lot of vendors out there that have mature technology. And the traditional approach to a gateway agent is to write it in Java and use a Java virtual machine to abstract away the operating system. If you don't write it in Java or some other way to abstract the operating system, you end up having to individually test every single operating system. And there are so many flavors of everything out there that it's just not realistic to think that you're going to go QA a bunch of different operating systems. And so the best way to do it is with, or in the past, it was with a Java virtual machine. But we never really liked that approach because it's heavyweight, meaning it limits the gateway's ability to scale down to lower cost silicon. And in the context of Intel, the Atom silicon is a good mix of performance and low cost. And so that's really popular to put in gateways. But if you, all of a sudden, the first thing you do is you put a Java virtual machine on top of that thing, then all of a sudden you just took up a bunch of your compute. Not only that, but the licensing requirements of the Java virtual machine can make the total solution more expensive depending on which of the Java virtual machine vendors that you go with. And specifically in some of our verticals, the vertical specific middleware stack, it requires specific Java virtual machines. And so when that approach is taken, their entire cost structure is blown. So our approach is a little bit different. So we abstracted the OS specific capabilities using a Python interpreter. And that approach is lighter weight and it's free. So far, the Python approach to writing a gateway agent has been That approach has been awesome. We are thrilled with the results, and our testing has been very positive. In the beginning, we were a little bit concerned about the performance of a interpreted language, but our testing has shown that it's actually quite good, and it's fast. And it's been very well received by all of you out there in the development community. The development community loves Python, and so it's been a win-win for everyone. It's been a great way to abstract the operating systems. So now we can go out there and say, hey, if you support Python 3.4 or Python 2.7.9 or anything greater than that, then you're good to go. And it's been a fairly easy prerequisite to have for our agent software. And we've done a bunch of testing, and it's all been positive. Okay, so security. So security is a hot topic. I've already mentioned it a few times, but let's just go into a little bit more detail. Across every stage in the device lifecycle, Device Cloud will help you protect your deployment with some built-in security. These security capabilities, we put these in 3 primary categories: confidentiality, integrity, and availability. So starting with confidentiality, this includes the basics of encrypting the communications from device to cloud, and we mitigate risk on the device by running the necessary privileges in order for those agents to perform their duties. Other security basics include things like things like password resets and role-based access, all to prevent some unauthorized activity. Next is integrity. For us, integrity involves mutual authentication and signed update packages. Mutual authentication means that both the server and the device, they exchange certificates to make sure that both the server is the right server and the device is the right device. Customers, they also get automated file checking, logging, and data buffering, so your standard stuff there. Lastly, Device Cloud offers 3 nines of uptime and 24/7 monitoring. And so this around-the-clock monitoring is really important for customers that run in different time zones or different super geos. Device Cloud, we provide protection against DDoS attacks, spoofing, forgery, and which all helps keep your devices securely connected. And most importantly, all these capabilities are enabled at scale, ensuring strong performance and deployment as you start to scale your business. All right, so quick check here. Any questions? I still see no questions in the chat screen, so I'm assuming that we're good to continue to move on. So just a few examples of how customers have taken the technology and put device lifecycle management into action. I have 3 examples for you today. So the first one, it's a market-leading provider of parking systems, and they saw an opportunity to expand its urban mobility offerings in beyond parking meters. So this company, they have a parking meter offering where you go and you put your credit card in these days, right, and you get the printed ticket, put it in your dashboard. So they provided that, and they wanted to take it a step further. So they're looking at things like coupons, Wi-Fi access, electric vehicle charging, surveillance, air quality management, emergency alerts. And so they needed a provider with IoT device management capabilities to help them transform its business. So they look to us, and with Device Cloud and Intel, they're able to fuel steady innovation as it moves from the parking business to become what they call an urban digital solution provider. And so we're happy to help them do that. The next company I'm able to mention by name, it's Waterous. We're talking about smart fire trucks here. So we consider this part of the smart city and emergency services space. And Waterous, they're the leading manufacturer of water pumps for fire trucks. They turned to us to help them take their firefighting products into the digital age. And so they launched the industry's first digital touchscreen control. And with this new solution, the operators can configure the fire suppression foam mixtures while the truck is en route. And so for each type of fire, you have a different type of foam, and they have the foams are mixed while they're being shot out of the hose, and they needed to be able to configure those remotely while it's en route. And this saves them a lot of time when they're actually getting ready to fight the fire. And technicians, they can also provide support remotely. This is where the remote management comes into play. So with Device Cloud, it enabled Waterists to do things like manage the device lifecycle of their new product remotely, and do things for everything from configuration to testing to updating. And so for Waterists in their own product development lifecycle, we are able to make it more rapid for them to iterate their code base by providing device lifecycle management services. So when their own development department came out with a new release, they used our infrastructure to push that new release out. And so it shortened their development cycles as well. So it's not only helped in operation, but also in development. Next is we help them troubleshoot issues and perform preventative maintenance. And it also enabled superior customer service because the technicians didn't have to drive out every time. And they got a first mover advantage. All right, the last use case I have for you today is an oil and gas market leader. They wanted to pull data from their existing sucker rod pump controllers, and they had new wireless sensors that they wanted to connect through a gateway to the cloud. And so they turned to Wind River and Intel to securely manage the remote onboarding process of the gateways and remote devices. And so if you remember from my slide earlier, I talked about zero-touch provisioning with the Intel Secure Device Onboard technology. And so this customer used it. They loved it because they didn't want to have to retrain their entire field support staff in IT skills. Their entire support staff, they turn wrenches and they know how to do the heavy iron stuff. They don't know IT skills. And so for onboarding, it was a real problem for them because they would have to essentially take all those wrench turners, pull them in, retrain them in IT, and put them back in the field. Instead, they use Intel Secure Device Onboard, and it saves them the hassle, and it makes things a lot easier for them. All right, so these pumps, they're located in remote areas, and so the price of a truck roll is very high because if something breaks, the guy has to jump in his truck, drive out there. And while the pump is down, it can cost hundreds of thousands of dollars while it's down. So with remote support, the technicians can troubleshoot issues without having to physically interact with the devices. So that means that they can detect the need for maintenance before the thing breaks, so they can prevent the breakage, and they can create efficient routes so that they can identify the 5 pumps that are near each other and service them all with the right parts and do it the first time, right? Because not only is it important to understand when the device is about to break, you also have to understand what's wrong with it, because you might not bring the right part out with you, and then if you discover the breakage and you don't know what part it is, and then you don't have the right one, you have to drive all the way back to home base, grab the part, and then drive back out to the field. And with remote devices, that all of a sudden consumed a bunch of your time. Okay, so we're starting to wrap up here. Device Cloud is built on Intel and Wind River's long-term experience and commitment. The IoT stack required for the entire solution stack, it needs a diverse set of skills that include embedded development, networking, security, cloud, and DevOps. And only a company like Intel can bring it all together with all these disciplines at scale to create a next-level product with Device Cloud. So Wind River has been in the embedded space, like I was saying, for 35 years and sold software to a variety of industries from aerospace to automotive and industrial to healthcare. And this has resulted in more than 2 billion devices around the world running Wind River software today. So we continue to demonstrate the ability to overcome challenges associated with embedded development, and we've applied that experience to Device Cloud and specifically the agent technology. And so we also use the Intel security group's tried and true tested security solutions also with the Intel hosting services. And so by having such a big company, we're able to draw upon all these different areas of expertise. So to tie it all together, secure device lifecycle management is the only way to future-proof your IoT deployment. So please, IoT safely out there and include device management capabilities into your solution design. We would be thrilled if you would consider Wind River Helix Device Cloud, but please, just choose something. Thank you. Thanks again, everybody. Appreciate your time. Hopefully you found this useful. Have a good day.